In this video I'm going to cover how to draw a detailed thread representation in AutoCAD. I'll be using the techniques outlined in the technical drawing text by Gasecki. So I would highly recommend that you follow along in the book as I go through the video here, and that'll help you fully understand what I'm discussing. Um, this is a thread note, okay, and this contains the information that you'll need to properly construct the drawing, the detailed thread representation. And so you need to understand what is actually written in the thread note. So that's the first thing I'm going to go over now. This is actually one of the or at least as of the making of this video, this is one of the assigned detailed thread representations that you'll actually be drawing. Of course, you'll have a couple more to do, but the first number, of course, that's subject to change. The first number is 1.5 inches. Okay, that means that the major outside diameter of the thread is 1.5 inches. The 6 indicates that there are 6 threads per inch on the screw thread. You can use that number to calculate the pitch. The pitch is equal to 1 over the number of threads per inch. So in this case, the pitch is equal to 1 over 6. UNC means unified course. That's a unified course thread type. The 2 in 2A indicates that this is a class 2 fit. That's really just for thread notes and isn't going to have impact on the actual way we draw the thread, but it's important to know that that is a class 2 fit. The A indicates that this is an external thread that we'll be drawing. If the A were a B instead, that would indicate that this were an internal thread. The RH is actually extra information that doesn't need to be in the thread note, but it's just placed there for your benefit. Typically, and the RH stands for right hand turn thread. Typically, if you don't see an LH in a thread note, then you're to assume that it's an RH, and of course an LH is a left hand. So again, if you don't see RH in a thread note or LH, you are to assume that it's an RH. One thing that's omitted purposefully and correctly from this thread note is that this is a single thread drawing, and what I mean by that is if this thread that we were about to draw were multiple threads, either a double, triple, or quadruple, then you would actually see the words double, triple, or quadruple immediately following the class of fit. Since we don't see the words double, triple, or quadruple, then we're to assume it's a single thread. And of course, each one of those threads, single, double, triple, and quadruple, would greatly impact the way that you would draw the detailed thread. So it's important that you know that. And so we're going to draw this as a single thread. You should start off with your standard class template and title block, so you'll have the correct layers and everything that you'll need to properly construct this drawing. I'm just going to start off with a center line. This detailed thread, we're going to draw it at 4 inches, okay, 4 inches long. So I'm going to start off just by drawing a center line approximately 5 inches long. Okay, it doesn't have to be exact. We're mainly going to use it for construction. Okay, so since my outside diameter is 1.5 inches, I need to offset this line above and below the existing center line by 0.75. So O, enter, 0.75, enter. So offset above, offset below. And now we're drawing this 4 inches long. So what I'm going to do is I'm going to draw a line from midpoint to midpoint, and then I want to offset in each direction by 2. So O, enter, 2, enter. I'll offset to the right, offset to the left. Now let me place these lines on the correct layer. I'll put them on the visible layer. Do a little trimming, TR, enter, enter. And I will erase the line in the middle. And now I have a rectangle with a length of 4 and a height of 1.5, which is the major outside diameter, okay, and a center line running directly through the middle. And that's how we're going to start. Now, since this is a single thread, we're going to make an offset on this vertical line on the right here to the left by half the pitch. Okay. Now, if this were a double, triple, or quadruple thread, you would not do this by half a pitch. You need to reference your textbook. But for a double thread, you would actually make this first offset by P. For a triple thread, 1.5 P. But in this case, since this is a single thread, we offset by 1/2 P. Okay, so O, enter. And if my pitch is 1/6, half of that would be 1/12. So 1 divided by 12, enter. And I'll offset that way. Now, since this is a right-hand thread, that means that the slope of the thread leans upward and to the left. Okay, if this were a left-hand thread, the slope of the thread would lean upward and to the right. Okay, so again, right-hand thread leans this way. All right. Oh, let me put myself on the current. Make my current layer the visible layer. Okay. Now I want to erase that vertical line there. The next thing I want to do is actually copy this line to the left by the pitch. Okay. Again, the pitch in this case is 1/6. So I want to copy directly to the left, and I'll snap on. I can snap on the end point here, and you want to make sure that you see the green polar tracking line, or you can use ortho or what have you. Just make sure that you're going directly to the left when you do your copy, and then put 1 divided by 6. Okay. To make sure you did that right, you might want to zoom in and make sure that the end point actually touches that line. Now, a lot of people, let me highlight that line in yellow just to show you something. A lot of students would want to just offset this line by 1/6, and that is not correct. Okay, remember, offsets by parallel. Okay, so if I were to actually offset that by 1/6, you can see that the offset line ends up in a different place than the copied line. Okay, the copied line is correct. This is the offset line, and that is incorrect. Okay, that's just a little geometry there, but the distance between crests on a screw thread should be equal to the pitch. Okay, so 1 divided by 6 is 0.1667. Okay, so that is the correct line. All right, so let me use MA, and I want to change that back to the visible line type in red. And now the detailed thread representation has 60-degree angles between the crest and root of the thread. Okay, so I'm going to create those now. Make sure that your polar tracking has some kind of increment that divides into 60. So 10, 5, 10, 15, any of those would work. 30 would work as well. But you'll use your polar tracking to accurately place these 60-degree angles. Okay, so it actually says 120 on the arc there, but just hold on just a minute and you'll see where I'm going with this. This one says 60. Let me trim that, trim this, and you'll want to check your angle just to make sure that is in fact 60 degrees. Now, a lot of people get excited when they see 60 there, but the thing is that there are no decimals showing, so we need to make sure that even with 4 decimal places that we see all zeros, and it's exactly 60 degrees. So I'll click on that. I'm going to have to change my dimension style to standard so I can get the actual precision I'm looking for, and then I will right click, change the precision to 4 decimal places, and I have 4 zeros. So that means that we are exactly 60 degrees, which is what we want. Now I want to erase that, and I'll do the same thing on the bottom. Okay, and then do some trimming here. Just real quick, I want to check my angle.